Hello everyone, welcome back to Amaze. In this video, I am going to start with chapter number 4, quadratic equations. And basically, in this video, particularly I will be covering introduction to quadratic equations. So let's start with the same. So as I have already covered in previous chapter, that equation means wherever we are having equal to sign, right? So if we are having, let's say, x plus y equals to 1, this is an equation, right? If I have, let's say, 5x plus 1 equals to 0, this is an equation, right? As we are having an equal to sign and there is something here in the LHS and here in the RHS, right? Now, we have seen in chapter number 2 polynomials that there are different types of polynomials like linear, quadratic and cubic. So have you remembered what was quadratic polynomial there? So quadratic polynomial was the polynomial with degree 2. Degree means the highest power, right? So let's say if I am having x square plus 5x plus 1. This is a polynomial and the degree of the polynomial is 2. Hence, this is known as quadratic polynomial. Similarly, if the degree of the equation we are having is 2, then we will say it as quadratic equation. So it's as simple as that. If I am making it an equation, okay, it's an equation now because I am having equal to sign. There is something on LHS and there is something on RHS, right? So obviously this is an equation, but as the degree of the equation is 2, this is a quadratic equation. Clear everyone? So again repeating, what do you mean by quadratic equations? It's an equation with a degree 2, right? Now, one more thing we have seen in chapter number 2 polynomial, that is the standard form of the quadratic polynomial. So what was the standard form of the quadratic polynomial? It was ax square plus bx plus c, where a is not equals to 0. This was the standard form of the quadratic polynomial, right? We know this a is the coefficient of x square, b is the coefficient of x and c is any constant number. So here, what is the standard form of the quadratic equation? Okay, so the standard form of the quadratic equation is, as this is a polynomial, right? Quadratic polynomial, standard form. We will make it an equation. So the standard form is ax square plus bx plus c equals to 0, where a is not equals to 0. Right? So this becomes an equation and this is for the quadratic where the degree is 2. Right? So this is the standard form of the quadratic equation, ax square plus bx plus c equals to 0. Again reiterating, a is the coefficient of x square, b is the coefficient of x and c is a constant number, right? And we already know that a cannot be 0 because if a will be 0, then 0 into x square will be 0 and we will be having just bx plus c, which is not quadratic but linear, right? So for quadratic, it's necessary that a should not be equals to 0, right? So this is the standard form of the quadratic equation. Now, what is the use of the quadratic equation in real life? So first of all, let me tell you, whenever you are dealing it with area of a particular shape, okay, mainly we'll be using quadratic equations because you will be having a quadratic equation formed there. Okay. Second, we have also discussed how the quadratic graph looks like. It will be a parabola shape. Okay. Either a U-shaped parabola or an inverted parabola, right? Either opening upwards or either opening downwards. So this shape is known as parabola. So any quadratic equation when plotted will be having this type of graph. So let me give you one more particular real life application of this. That is, whenever we are throwing something from ground level or from a particular height, obviously it is going to have this trajectory like parabola. Okay, it is going to fall again back onto the ground. So mainly when we are dealing it with height and time or the distance it has traveled after throwing, we can use quadratic equation there to calculate a particular height at a particular time or to calculate the distance. Okay, and at particular distance what can be the height. So mainly height, time, height, distance we can use wherever we are having this type of trajectory. Clear? So these were the real life applications of quadratic equations. Now that was only it about the introduction part of quadratic equations. In the next video we are going to see few important questions of exercise 4.1, right? So that's it for this video. Thank you. Catch me up in the next video.